Now see, Fatima,
Ji.
I want to write a few equations. See, he used a lens,
Oh,
right? I don't know whether convex or concave, but this refractive index has a focal length, but this focal length is different for different wavelengths. And
yes.
because this lens is a material which has different refractive indices for different colors, right? Object is placed
Yes.
here. Object is placed here, maybe here, and image is formed here. This is object, this is image, right?
Yeah.
This is u position, this is v position. That generally we write object position u and image position v. What I am given to understand from the question is focal length is inversely proportional to 1 by n minus 1, where n is
Yes.
refractive index, right?
Yes.
Where n is
Index of refraction.
yes, index of refraction. So can I write f is equal to k by n minus 1, where k is proportionality constant?
Okay.
Yeah, do you have that experience converting proportionality into equality? We can write this.
Yes.
Okay. If I write focal length for red here, I should write r here. Focal length for red color should be equal to n or refracted x for red color here.
Yes.
Should I write focal length for violet color is k divided by nv minus 1 refracted x for violet?
Yes.
Okay. Now, should I use the formula 1 by v minus 1 by u is equal to 1 by f, right?
Yes.
That is the lens formula. Now,
it's minus.
yes, it is negative for lenses.
Okay, negative.
Do you use plus formula 1 by u plus 1 by v is equal to 1 by f for lenses also?
Right.
Do you use this formula?
Yes.
Both are valid. This and this both are valid. We generally here in India we use this formula 1 by u plus 1 by u is equal to 1 by f for mirrors, and we write 1 by v minus 1 by u is equal to 1 by f for lenses, because we have a Cartesian coordinate system of sign convention here. I think you are using a different sign convention. That's why you have the same formula for both.
Yes.
Now
we are using DO and DI.
DO and DI is U and V. But I'm afraid whether the formulation may be different you are using. American system is different for this case, but we will get the same answer.
Yeah. Right.
Anyway, this is the lens formula that we are using here. In this case, we take this U negative, V positive. Now he says, what does he say about? He says, just a minute.
Yes.
He says, now suppose the white object is placed 20 centimeters in front of the lens. So he says U is equal to minus 27 centimeters. U is taken as negative because it is on the left side of the lens system. This distance is negative, this distance is positive, right? And F is positive for convex lens. That's our convention. I don't know. Americans take a different convention, and that creates a lot of confusion. Anyway,
right.
Now see what I will do here. I want to find, because finally I had to find what is the final image formed when we use which kind of light? Violet image. Violet image, why the violet image will be formed. Let me first tell you where the final image is formed. Have a look here. See here. 1 by V is equal to 1 by F plus 1 by U, right?
Yes.
Good. 1 by V is equal to U is here plus F is here by UF, right?
Yes.
Good. Very nice. Now, what about V? UF UF. Okay, look at this formula.
Okay.
Good, very nice. Chalo, no, let me not do this. Not needed. 1 by V is equal to 1 by F. What is 1 by F? 1 by N minus 1 plus 1 by U. Is that right?
Okay.
Because don't you know
Yes.
F is equal to K by N minus 1?
K by N minus 1. Yes.
Have you written this F is equal to K? Because he says inversely proportional to, right? So 1 by V equal to this
Yes.
go up. N minus 1 plus 1 by U, right?
Yes.
Good. Okay.
Yes.
Now, it is final image. What is 1 by V, Fatima?
What is V?
V is position of the final image. It is
Yes.
K
V
times.
is final image.
K times by K.
Yes.
Right?
Yes.
Good. That's right. Should I write N minus 1 by K is equal to 1 by V minus 1 by U? This.
Yes.
Okay. It's N minus 1. N, I have to find which image is given, which image position is given.
The red position.
Red position is given. Red light reflect from the object. It was a shore. Yes, red position is given. And R minus 1 by K is equal to 1 by, why the image is formed in case of red object? V, okay,
50.
V red minus 1 by U. Okay. I should write for violet also. N violet minus 1 by K is equal to 1 by V violet minus 1 by U. Same, this is the equation. I read the equation for red, I read the equation for violet. Isn't this fair? Fatma,
Yes,
this is the final equation I got, right?
Yes.
How can I write this equation for red? N red, refracted x for red minus 1 by K. 1 by final position for red image minus 1 by U. What is U? Object position.
Original position.
Object position. Should I write object position for red?
It's the same for both red and violet.
Very nice, very nice, very nice. You are quick to understand. I am so happy. Okay. Because it is same for both. Why should place red and violet here? Now I will divide. Because I was not knowing this K, so I wanted to get rid of this K, right? So NR minus 1 by NV minus 1 is equal to 1 by VR minus 1 by U divided by 1 by VV minus 1 by U. This equation will give you the answer. Substitute for NR, substitute for NV, substitute for VR, final position for red color, that is given to be 53. 1 by V, you have to find this. 1 by U, no. All these things, you have to find 1 by V. Can't you find it?
Oh,
first,
I'll find it.
Yes, first you calculate this, then in a very coordinated, and in a very careful manner. You just calculate this and this, and then this, and then this. Then you keep it like this, because you have to find it and substitute this, and finally you find 1 by VVR, position for y. Position for.
Okay.
Can you do it now?
Violet. Yes, I can do it.
Should I give you a shortest method?
No, I think ये ठीक है. हम next वाले तरफ चले जाते हैं. ये मैं plug कर लूँगी अंदर.
चलिए, good. That's right. What's the next question?
Next one is 25.63.
हाँ, बोलिए.
वो मैं 25.63 milliwatts laser produces beam of light with diameter 1.2 millimeter.
Okay. First, let me make the diagram. This okay, this is a circle having a diameter of what?
1.2
millimeters, and it produces a laser beam, radiation beam. Radiation
Yes.
beam is through this diameter, through this circular circle, this radiation beam, that is power is equal to 0.60 milliwatt. What is the question?
Yeah.
What's the average intensity of this beam? I define average intensity. Look at this. Intensity is defined as power per unit area. Power is 0.60 millivolt 10 raised to the power minus 3 watt divided by area, that's pi r square. That is 0.60 into 10 raised to the power minus 3 by pi is 3.14, and r square is the radius is half of this. That is 0.6. 1.2 divided by 2, 0.6. Because radius is half the diameter, into 10 raised to the power minus 3 square of it. It is 0.60 into 10 raised to the power minus 3 divided by 3.14 into 0.6 square into 10 raised to the power minus 6. Calculate this.
Okay.
Intensity is nothing but that's power per unit area. How much power is for a unit area? That is all. This is the energy passing through this area, and per unit. You just calculate this. I want to see the answer.
Okay.
How much is the answer?
The answer that they say is 0.53.
And what is yours?
Kilowatts.
What is yours?
I'm getting 53 kilowatts.
The same.
I mean 0.53 kilowatts. Yeah.
Are we getting the same answer?
Why was I having trouble? Yes, yeah. Acha.
Why?
I don't know. पहले जब मैं कर रही थी नहीं आ रहा था. I don't understand. लेकिन और ये मुझे पहले भी पता था कि intensity power over. I don't know.
Let me do.
अब सही आ रहा.
It is 0.53 into 10 raised to the power 3 watt. It is 0.53 kilowatt. Is that right?
Yes.
Any other question?
The part B.
What is that?
It says, at what distance does a 160 watt light bulb have the same average intensity as found for the laser part A?
At what distance does a 160 watt bulb have the same average intensity as that found for the laser in part A? And what is that?
Assume that only 5%.
Power is converted into light. Okay, now see, have a look.
Yeah, I know how to solve this.
Okay, good. कोई बात नहीं.
Point 50.
Let me give you a hint, or let me give you the right equation. This is the power of this, right? This is the intensity of this. Of this power. This is the intensity. Now keep this intensity in your mind, right? Keep this in your mind.
Okay.
I may forget, but you have to keep it in your mind. Now there's a bulb. It radiates energy, right? And at a distance, how much energy it radiates? How much power it has? 160 watts.
It has 160 watts. Yes.
And can you tell me at a distance R, what is its intensity? This power has to pass through this sphere, right?
Yes.
What is the power? What is the intensity? Sorry.
Power over pi r squared.
Good. 4 pi r squared. It is this whole sphere, whole sphere through which this energy passes.
Right.
Imagine, you see, Fatma, imagine there's a bulb. It radiates energy. I want to find power here, intensity here. I have to draw a sphere. How much this sphere receives energy from this bulb? This sphere, how much the energy this sphere receives from the bulb? The whole of it.
It's the power divided by the entire area of a sphere.
Yeah, that is the energy through unit area passing out of this bulb. Because whole area will receive that energy. But we have to find the energy per unit area. Imagine there's a bulb and you cover this bulb through a sphere, by a sphere. How much energy is striking the sphere? Whole.
At the entire sphere?
Yes, the energy, suppose there's a bulb and you cover this bulb by a sphere, hollow sphere. That means energy falls on the whole sphere. And how much energy unit area of the sphere receives? That is that power that it emits.
4 pi r
squared. Okay, this is the intensity here. But now he says only 5% of this power reaches here. Only 5% of this power converts into light. So it is 5% is 0.05 of 160 4 pi r squared, this distance, small r squared, is equal to that 0.53 kilowatt into 10 raised to power 3. You will get the answer for R. He says at what distance the power will be the same as that which you got in the earlier concept. But here the energy is only 5% what it emits from here. So you have 0.05, that's 5%. So if I use this equation, I will get the answer. This is the intensity at R. But what percentage of this intensity will survive at this distance? He says only 5%. So R square is equal to 0.05 into 160 divided by 4 pi into 0.53 into 10 raised to power 3. Square khatam ho karke root ho. If you calculate this, you'll get the answer.
Yeah.
You follow that? Or should I be very slow? This put R square here, then put it here, and then calculate.
Oh no, I can do it.
I want that you should let you get the answer. Let me see whether I am doing things correctly or not. Because
I got the answer.
You got the answer, but you'll get an answer in meters, right?
I got it in meters, but I converted to centimeters and got 3.5.
That's great. Your analytical capability is quite good. It will take me a while. Honestly, you see, it will take me a while. Even my using my calculator.
No, I have a very nice fancy calculator.
That's right. Good, very nice. Okay, any other question you have? Yes, Fatima. Any other question?
Last question. जो next वाला 26.6 आप ऐसे swipe करेंगे तो next वाला.
Is it the last one?
Yes, last one.
Okay. Okay. So let me close this now. What is the last question? Possibly this is the question.
20.
Is there?
Sorry.
Is this the question like this? And here is the mirror. Is it?
Yes.
And there's a light falling.
Yes, exactly.
Light falling like this at an angle of 32 degrees, possibly, and light gets reflected like this. Okay.
Right.
And then this mirror is turned around by putting a pencil underneath, and that shifts it 5 degrees upwards. This mirror gets shifted upwards 5 degrees, and that will shift this ray of light upwards like this.
Yes.
The question is, how much is this distance, delta y? How much the ray of light will get shifted upwards? That's our question.
Yes.
Okay. That's good. Now please tell me, if this is 32, what is this angle? And what is this distance? 2 meters. Is it 2 meters?
Yes, distance is 2 meters.
If this is angle 32, what is this angle?
32.
Good. Because incident angle is equal to reflected angle. This angle is equal to this angle. If I draw a perpendicular, this is equal to this, right?
Yes.
If I get this angle somehow, I am done. I solved the problem.
Mm-hmm.
If I turn this mirror by 5 degrees, if I can know somehow through what angle this ray of light will shift upwards, if I find this angle, I am done. Can you tell me that?
If it went 5 up, it should also go 5 up that way. So it's
Good,
5
good,
degrees.
Very nice. Good. Very nice. Very nice. Tell me again, if this mirror goes 5 up, what will happen to this ray of light? How much up it will go?
It should also go 5 up.
Okay. That is the common thinking with the students.
Yeah.
But I say it goes 10 degrees up.
Mm-hmm. But why?
Should I tell you how?
Yes, please.
Okay. Now, this is a mirror. Is it?
Yes.
Have you experienced if you throw some light on a wall by your mirror?
Yes.
Sometimes you throw some light on the wall by your mirror, and you just turn a mirror a little bit, and the reflected light goes very, very high onto the wall. Have you that experience?
Yeah.
Just by turning
Yes.
the mirror a little bit, the reflected light goes very, very high. Anyway, okay, this is ray of light here. Yeah. This is reflected light.
Right.
Okay. Now, what about this this angle of incidence?
Yes.
This angle of reflection. They are
right.
They are equal. And yes. It was good when you said this angle is also equal to this angle, right? Can you tell me?
Yes.
What's the deviation? Had there been no mirror, the ray of light would go straight.
Right, it will go straight.
But there is a mirror, it will not go. It will go like this. So it goes in this direction with the mirror. So can you tell me what deviation the mirror caused?
It caused the that whole from the real ray to the dashed ray.
That's good. That's good. This one. This is deviation due to the mirror. So what is the deviation equal to? 180 total angle. This one minus 2i.
180 minus.
Because this is I plus I, 2i. Total angle minus this angle is equal to this angle.
Mm-hmm.
Understood?
Yes.
Total angle?
Yes.
Total angle is this. That is 180. What to subtract? This one. Okay.
Right.
Should I show you once again?
Yes.
This is a mirror. This is ray of light. This is reflected. It will go straight. This is deviation. This is 2i. So deviation is equal to that. Deviation is equal to total angle. That is 180 minus this is 2i.
Right. Yes.
Now, what is change in deviation? That is this. Change in this is deviation. The moment this reflected ray goes up, that is deviation increases. Suppose this reflected ray of light goes this way, that means deviation increases. So it is the reflected ray which determines the deviation. So what's the change in deviation? By causing the change in the incident ray of light, by changing this, deflecting the mirror, this I means deflecting the mirror. So change in deviation, have a look, change in deviation is equal to change in 180, that is 0, it's a constant, it's no change, minus 2 times change in the current. So deviation is 2 times the deviation in the incident ray of light. Incident ray of light means when you push the mirror up and down. So that means if you change the mirror, if you deviate mirror by 5 degrees, the deviation will change by 10 degrees, 2 times.
Yes.
Pushing the mirror up and down means simply that you are changing the incident ray of light. You understand my point?
Right. Yes.
So that means if you change incident ray of light or mirror position by 5 degrees, how much is the change in deviation?
2 times 5.
Okay, 2 times 5. So that's it. It is now 10 degrees. Now I will solve the problem. You must know, if the mirror is shifted by 5 degrees, the reflected light, this reflected ray of light will deviate by 10 degrees. That was the question. Now I will show you the whole thing. Have a look.
Oh, then I know how to solve afterwards. I just didn't know how to get 10 degrees.
Okay, that's good. That's very nice of you.
Mm-hmm.
32 degrees. Now you shift 5 degrees, now it will go like this. It is 10. It is 32. It is 10. It is, I have to find. Let me suppose this is y1. This is y2. So this delta y is what? y2 minus y1. What is y1? From this triangle, it is 2 meters. From this triangle, tan 32 is equal to what? y1 by 2.
Opposite over adjacent. So
perpendicular by base.
y1 by 2.
So what is y1?
Yes. y1 is 2 times.
Similarly, what is y2?
42.
What is y2? Twice 10?
32 plus 10.
42. This triangle, the biggest triangle, tan 42 is equal to perpendicular, that is y2 by 2. The big angle. What is that? 32 plus 10.
32 plus 10, yes. So it's 42.
From there you get this y2. So what is y2 minus y1? Twice that y2 minus y1 is what you have to find. Delta y.
Yeah.
That is 2 tan 42 minus 210, 32. That is 2 times 10, 42 minus 10, 32. Find these values. What's 10, 42? Use your calculator.
40.
Let me use mine.
0.9.
Are you sure?
Yes. And 1032 is 0.6.
Is that the correct answer?
Yes.
Into 10. That is 0.9 minus what is 1032?
0.625.
Yes, 0.625. Subtract 0.9. That is
275.
2 into 0.275. Multiplied by 2.
Is
55.
0.5. Yes. Meters.
0.55 meters. Maybe it is 55 centimeters, right?
Exactly. Yes.
What is the answer?
55 centimeters.
Am I giving the correct answers?
Yes.
Anything else? आज के लिए काफी?
No, that जी अब बस इस एग्जाम की मैं अब सारी तैयारी करूं आज रात तक.
So, abroad. चलिए, best of luck. Allah support you. Allah help you.
Thank you so much, जी professor. Thank you. अच्छा, okay, Allah Hafiz.
खुदा हाफिज.